Pressure is a force exerted on or by a solid, liquid, or a gas. Pressure impacts many aspects of a fire. Changes in pressure can affect the travel of smoke, air, flames, and water, ultimately impacting firefighting operations. During the initial stages of a fire, gases are heated by the fire, which creates a thermal column or fire plume. The area around the fire plume is at a lower pressure than the ambient air around the fire. As the fire plume transports hot gas to the ceiling of the compartment, the gases become trapped by the ceiling and the walls. As a result, the pressure of the gases build up, and the smoke layer will extend down toward the floor until the gases find an opening, such as an open doorway, where they can flow to areas of lower pressure. Often these lower pressure areas are rooms or hallways next to the fire room, connected by an open door. This creates a hot, fast-moving flow of gases into the cooler areas with lower pressure. Smoke or air always flow from areas of higher pressure to areas of lower pressure. The flow path is the route that smoke, air, heat, and flame take between the fire and other compartments in the structure or the exterior through openings such as doors, windows, or other leakage points. The flow path can change as the fire develops based on pressure differences within a compartment or a building. Keep in mind that wind can also impact the direction of flow within a flow path. The flow path of a fire must comprise at least one intake vent, one exhaust vent, and a connecting volume between the vents. At the intake vent, fresh air travels into the fire compartment. Smoke and flames travel out of the fire compartment at the exhaust vent. Ventilation openings are the beginning and the end points of a flow path and can be unidirectional or bidirectional. The vent is considered unidirectional when flow moves in only one direction. If a unidirectional intake vent is visible, this indicates that there is an exhaust vent elsewhere in the structure, usually at a higher elevation. Conversely, if a unidirectional exhaust vent is visible, this indicates an intake vent elsewhere in the structure, usually at a lower elevation. When a single ventilation opening serves as an intake and exhaust, the vent is bidirectional. The intake and exhaust portions are separated by the neutral plane, where the pressure inside the compartment equals the pressure outside. If the bidirectional ventilation is the only opening, the neutral plane suggests the extent of fire development. The intake portion of the opening will become smaller as the fire grows and approaches flashover. The connecting volume between the fire and an exhaust vent can be very dangerous. It consists of smoke, heat, and flames traveling very fast. Being between the fire and where the fire wants to go will put you at significant risk. Observing the location and flow from ventilation openings can help you predict how the fire gases are moving within the structure. Remember that there are often multiple flow paths in a single structure, and that any new ventilation opening will create a new flow path within the structure.